Hello student. Today lecture is started with this S parameter or fundamental of S parameters, in which we have deal with the basic of the S parameters. Before starting this lecture, I would like to say about some previous lectures notes in which we have studied the as fundamental of the Laplace transform, in which we have studied the basic of Laplace transform. So let's go for the further studies. Today I am going to teach you the fundamental of the S parameter. We all want to understand and predict how a circuit works. So we want to able to represent a circuit behavior by using mathematical expression or equation. S is a stand for a scattering place, and scattering place, and the starting place in the linearity. If a circuit consists of a linear element, then it can be represented by a set of linear equation relating its independent quantities like current and voltage to its dependent quantities, also current and voltages. This is a remarkable fact allow us to take a complicated circuit with lots of pieces, put it into the black box as shown in the figure. Yeah, this one. Put all these things into this black box, defined by voltage and current, and reduce it all to two linear equation relating this voltage and currents. If you know that before earlier, uh, this extensive use of high frequency system network parameter like Y and Z parameter were the primary method of categorize the circuit performance. At higher frequency, the concept of the voltage and the current become more difficult to relate the network performance, especially in the network using transmission lines like waveguide. So the S parameter are related to the power waves and avoid a lot of these issue. The S parameter refers to scattering matrix. Basically, it is defined as a scattering matrix of a microwave network. Means S in a S parameter refer to scattering rather than scattering. For an early reference, introduce the emerging microwave community to practical approach to solve a microwave design problem using scattering parameter in design of the circuit. It is helpful that during in the in an era of 60s, but today, before we get introduced in mathematics, let's define few things you need to know about the S parameter. So in figure you have seen that in this figure you have seen that S figure are useful method to represent the circuit as a black box, and in this black box the external behavior of this black box can be predicted without any regret for the contents of this black box. This black box contain anything: a resistor, a transmission line, or a integrated circuit. And the simple diagram of two-port network is shown here. It is quite easy to understand, all of you. Yeah, this is a terminal port of lines. This is basically two part of this black box. S parameter are measured by sending signal frequency signal into the network or a black box to detect what waves exist from each part. So go through this circuit. If yeah, if this is a black box, means incident wave is coming in this side, coming this side. Just wait. S parameter are measuring sending frequency signal into the network or a black box and detecting what wave exists from each port. So the power, voltage and the current can be considered to be a part of the waveform traveling in the both direction. Like this shown here, this is one wave is traveling like here, and this is a reflected wave, and this is a transmitted wave. For a wave incidence of the on a part 1, some part of the signals refer the blackout of this part, or the some pattern of the signal exists both of the other parts. So I have seen the S parameter described as a SS1 and S21, like two port network can be explained here. So first let's look the S11. If I have defined the S11, S11 refers to the signal reflected at a port 1 for the signal incidence at a part 1, and a scattering parameter S11 is the ratio of two waves B1 by A1. Reflected wave is defined by B1 and the incident wave defined by A1. I have seen S parameter described as a S11, S21, etc. can be explained. Now let's look the S21. S21 refers to a signal existing a part 2 of the signal incidence of part 1. See here, the incident wave is defined as A1 and transmitted wave defined as V2. Scattering parameter 21 is the ratio of 2 V21 and A1. I have seen the S parameter described in S11 and S21. Now let's look S21. S21 refers to the signal existing in the part of 2, the signal incident of this as a part 1. Scattering parameter 21 is the ratio of this 21. Yeah. See, as a combined altogether of this two network, that it can be seen like that. Transmitted wave is B1, incident wave A2, and reflected wave V2. S22 refers as a signal existing to part 2, incident signal of part 2 as part 2. S22 is the ratio of B2 by A2. B2 by B2 by A2. So this part of this part of the network is called the S22, and S12 refers of the signal adjusting at part 1 for the incident signal, and part 2 S21 is the ratio of B1 by A2. B1 by this one A2. Now, a linear network can be categorized by the set of simulated equation described by the adjusting waves from each part of the term, the instant wave. How can we have seen that the S1 defined it as the B1 by A1, where B1 and A1 were assigned. S12 is B1 by A2, S21 is equal to B2 by A1, and S22 defined as a B2 by A1. Now again, how to subscribe the follows the parameter of the ratio of such ratios. See, in this figure we have seen that the incident wave is coming in two-port network, and transmitted wave traveling outside the two-port network, reflected wave obviously shown this on this way. The transmitted and reflected wave will have a change in amplitude and the phase from the incident wave. Generally, the transmitted and reflected wave will at the same frequency as the incident wave. S parameter are the complex, that is, they have magnitude and an angle, because both the magnitude and the phase of the input signal are changed by the network. This is why they are sometimes referred as a complex scattering parameter. These four S parameter actually contain 8 separated number. The real and the imaginary part of each of the four complex scattering parameters. Quite often we refer to a magnitude only as a most interesting. How much gain or loss you get usually more important than how much signal has been phase shifted. So what do the S parameter depends on? The it depends on the network and the characteristic impedance of the source and the load used to measure it, and the frequency is measured at. If the network is changed, the S parameter is also changed. If the frequency is changed, the S parameter also change. If both the impedance of change, the S parameter also change. If the source impedance is changed, the S parameter. These are the parameter in which we have the S parameter depends. If either of any one of the parameters is changed to the network, the S parameter will be changed. Now, if this black box written in a form of matrix 2 by 2 matrix is look like this. This is a matrix algebra representation of two port S parameters. Some matrices are symmetrical. Asymmetrical matrix has with symmetry about the leading diagonal. Some matrices in the case of two port network, that means that the S21 is equal to S12, and interchanging the input and output port uh, does not change the transmission properties. A transmission line is an example of symmetrical two-port network. The best example of two-port network. Parameter also be leading diagonal S11 and S22 of the S matrix is referred as a reflection coefficient because they refer to the reflection occurring at the port only. Of diagonal S parameter, this diagonal parameter is this S12 and S21. S12 and S21, this one are referred as a transmission coefficient because they refer to be happen from one part of the network. If we consider as a larger network have any number of ports, means n number of ports, and the S matrix of the n port contains the n square coefficient of the S parameter, each of processing the possible input path. The number of rows and columns of S parameter is equal to the number of ports, and for the S parameter subscripts I and J is the part of excited to the ith of the output port, and this ith port or J port is a logical one. So the network maybe have any number of ports. The S matrix for the n port contains the n square coefficient of the n power S parameter. So if we consider the 4-port network, this is the 4-port network and the matrices are written like this. So this is a basic giving the basic knowledge as per the basic knowledge of S parameter. So if we conclude the S parameter, The S parameter are the powerful way to describe the electrical network. S parameter changes the frequency, load impedance, source impedance, networks, and the S11 is obviously the reflection coefficient. X22 described as the forward transmission coefficient, and the S parameter have the both magnitude and phase information, gives them magnitude and the phase information, and the sometimes the gain is more important than the phase shift, and the phase information may be ignored. So S parameter may describe the large and the complex network. If you would like to learn more, please see me the next slide. So this is the last this is the all about the S parameter, this in which I have give you some basic information about the S parameter. Now I'm going to end my lecture. Thank you.